Okay. Good evening, everyone, and once again, thanks for joining. Sorry, I had some connectivity challenge here. That's why it has taken longer, but finally I'm here. Before we start, please confirm whether you guys can get me loud and clear. Please let me know whether I'm okay. Okay, that's fine. Thank you. Thank you for that, guys. Thank you. Okay, so I'll go ahead and share my screen. Is it visible? Okay. Okay. Thank you. Thank you. So I want us to look at address resolution. Address resolution, or rather the address resolution protocol. So if you look at the main objective that we have here, that is upon completion of this particular module, the trainee should be able to explain how ARP, that is Address Resolution Protocol, and ND, Neighbor Discovery Protocol, in this case for IPv6, enable communication on a network. Enable communication on a network. So we'll be looking at the MAC address and the IP addresses. Okay, the roles of the MAC address and the IP addresses. Why do we need the ARP? And for the case of IPv6, why is ND or NDP important in our case? So we're going to look at the operation of this and see how important, all these protocols, help when it comes to communications within our network. So these are the most important addresses when it comes to communication of packets or frames within our network. So what happens when devices communicate within the same network? What happens when devices communicate on different network? In terms of these addresses, that's the most important question that we need to ask ourselves here. So as we have said, we have the physical addresses, which in this case is the MAC address. That is the layer 2 addresses, mainly used for NIC to NIC communication. That is communication within the same network. Communication within the same network. Then also we have layer 3. That is the IP address, the logical address used to send the packet from the source device to the destination device as well. So that is to say that for communication take place within the network. Whether it's voice call we are making, data, that communication is possible because of this what? Because of these addresses. So addresses are being used to deliver frame from one NIC to another on the same network, as you have said. So in that case, that is to say, if your destination is on the same network, then in that case, that the destination MAC address is what will be used to deliver, that frame or that particular packet within the same network, within the same networks. So in our case, if you look at, for example, what we have here. So this is a LAN, a local area network. It's a local area network. And you can see all these devices, PC1, as you can see, the switch, and PC2. They belong to the same network. They belong to the same network. And if you look at the table, our table here, the RP table, you'll find that we have the destination MAC address and source MAC address being indicated, including the IP addresses. That is the source IP address as well as destination IP addresses. So it is important in this case, when data is on transit, you should be able to capture the details or the address of that particular data on the device that received it on the network. So moving from point 1, point 2, point 3, point 4. So we'll find that if I'm leaving point 1 to point 2, so what is entailed within this particular data? Is it the same address that we have when it was leaving point 1? Or is it a different IP address on that particular device that it has reached? And that's what even the Wireshark keep on, when you run your Wireshark, if you want to check, to examine, basically, by the way, we're just examining these addresses as data is being moved from one point to another. So that's the main point of this. How about on a remote network? Okay, now this is actually where the destination is on a remote network, is not on the same network. And that's why you can see, okay, we have different IP addresses. You can see this is a class A IP address, 10.1.1.0, that's a class A IP address. You can see 209.165, which is also a class C IP address, and 192.168.10.0, a class C IP address. So the difference between the two, 192.168.10.0 and 209.165.200.224, 209 is a public IP address and 192 is a private IP address, though from the same class. So that's the main point. That's the main point that we have there. So as packet or as data leaves from PCA, okay, all the way to PC2. So we need to check the MAC addresses and the IP addresses. So from PC1 to this R1, so we have A and B, where A becomes the source, okay, and B is your destination. So assuming the data is on R1, okay, it's leaving this point R1 to now R2. Of course, we don't expect the source MAC address to be the same, because now it is originating from R1, not R2, not R2. So in that case, what was the destination now become the source, and where it is being destined to become the destination. So that's the point there. Until it gets to PC2. So the moment it gets to PC2, the source and destination MAC address, remember MAC address, not IP address, MAC address, when you check it later, it will not be the same. This table here will be populated with other details when it gets to PC2. So which one is your source and which one is your destination? So that's how things, are moving. That's not how things are moving. So that's something that I want you to take note of as, when examining, because the main objective is to examine these addresses as data is moving from one point to another. Now, then what is the importance of this protocol, ARP? Okay. Now, as you can see, a device will always use an ARP to determine the destination MAC address of a local device when it knows its what? IPv4 address. I have your IP address. I don't have your MAC address. I have your layer 3. I don't have your layer 2. Okay. So this is actually why the ARP is now coming in to resolve that IPv4 addresses to MAC addresses. And that's why you can see H1 here. So we have H1, H2, H3, H4. So H1, I need to send information to 192.168.1.7. In this case, H4 or host 4. But I only have the IP address. Okay, I don't know the MAC address of the device that has that IP address. So what happened in this case? Broadcast. Because we don't know who is who, you'll be broadcasting to find out whose IP address is this. Respond back with your, MAC address. Resolving IP4 addresses to MAC addresses. The function of the ARP is the mapping. Within the ARP table, we expect these addresses to be what? Mapped. So it maintains that ARP table, okay, of these addresses, IPv4, to MAC addresses being mapped within the ARP table. So that one will be there. So in that case, if we check the ARP table of each and every device here, what will be populated within these particular addresses, tables, will be not your own address as that PC, but the address of the other device on the network. So we'll be able to, after this, we'll be able to see whether, that's what, or that is true. So that's the point there. So those are two major functions, resolving and doing the mapping of these addresses, that is IPv4 to MAC addresses. And therefore, that means that there will be a search. Yeah, there's a search just to find out, be it on the same network or be it on a different network. But now, if it is on the network, the same network, which device are we targeting? If it is on a different network, which device are we targeting? Okay, so in that case, for example, if we are on the same network, as you can see, PC1 is connected to PC2, but on the same network. PC1 is communicating with the PC2 on the same network, or PC3 or PC4, whichever are the PCs. So in that case, I'll do a search on that ARP table for that particular destination IP4 address, just to find out whether, have the same on my end, because now I'm targeting you, I'm coming to you. So that mapping must be there. It has to resolve these issues of the what? IP4 addresses to MAC address, because mapping now will come in that sense. How about if it's on a different network? Okay, so you don't expect me to skip the central device and pick your address, because if it is on a different network, it means there's a router that is linking those separate networks. We have routers separating the networks. That's what we know with the routers. It separates the network. It separates the network. So two different networks there. Okay. So in that case, I will target the immediate device that connects me, that is the router. And that's what they're saying. If the destination IPv4 address is on a different network, then the device will search the table for the default gateway. Because that default gateway is what will relay your request. If it is located, then its corresponding MAC address is the one that will be used as the destination MAC address. And that's now is what they're trying to demonstrate here. So PC1, and you see, we consider, even though you are moving to PC2, fine, but you cannot skip R1. So meaning your destination will be the router. Here on a different network. Then again, another request from now router, not PC1. being sent to R2 until you get to the final device. And that's why I'm saying the content of the RP table will keep on changing depending on where the data has landed. The data has landed. It will not be the same. How about if there's no entry? Okay, that is, can't find you. If there's no ARP entry, okay, found, then that's the point a request will be sent out, meaning now broadcast. Because I have, yes, your IP address, I don't have your MAC address, and I can't see that. It's not there. So it will be broadcasted on the network. Okay. It's like now shouting to find out where is it on the network. So if it's available somewhere, then a response will be sent back. If it's not there, okay, still a response will be sent back, but now a negative kind of response, meaning it's not being found, it's nowhere. So the source device being notified. And that's the point. It has no choice but to delete it or to remove it because you are nowhere to be seen. So that's what again being demonstrated. If you look at now, yes, the details which have been captured here. Okay. Sorry, the details that have been captured. But the question is, for how long are we going to have these entries? Okay. Because they are not permanent. So that again depends with a period specified. So we have the cache timer. When it expires within a given period, then we find that that particular table will be empty, no details. So it means as long as we are communicating, I love your details. As long as we are communicating, I love your details. That is within my table. The PC's, ARP table, it will be captured there. Sometimes it depends with the operating system. The cache timers that we have differs from one OS to another. Or sometimes you can just opt to remove it manually. You can opt to delete or to erase everything from that table. Remove it manually because it will not be there forever. Now, if you look at our devices, also the routers. So now for the case of the routers, this is how you can confirm or check show IP ARP. Okay. To check these MAC addresses and the IP addresses within the table and how it is mapped. For the case of the PCs, the end devices, this is how it's being captured. Okay. You can see the IP address and the MAC address against the IP address being captured here. So this is the mapping. This is the mapping we are referring to. It's the mapping we are referring to. Broadcast, yes, it's okay. It's okay. Okay. Now, it has some issues. Of course, there's that broadcasting, as we have said, and spoofing. Spoofing is the modification that can be done on the content of that particular device by the hacker. Because that request that you have sent out is being received and processed by every device on the local network. Remember, when it's being broadcasted, it means all the devices on the network will be able to receive the same request. But some will ignore it because it's not meant for them. Just like assuming you are in a certain area and I've called, maybe you are in one room, or you are, okay, let's take a good example of this in this class. I can call someone like Kevin. Okay. Of course, you know, everyone who is on this meeting, who logged into this meeting, will be able to follow everything. I'm calling Kevin, talking to Kevin. So you are following everything. But you're not concerned because now that's Kevin, respond. So the same thing also with our device on the network. When actually trying to, or sending out a request and being broadcasted. So excessive broadcast will have some reduction in performance. Okay. Excessive ARP broadcast will have some reductions in performance because you see, you're not the only one. And again, it's being sent to each and every device on the network. So it's not of a unicast. Okay. Unicast is only possible when that mapping has been done. And what is this mapping in this case? Of course, if I have your number, I'll just call you directly because I have your number. What if I don't have your number? Okay. And maybe I know someone, I want to find out from someone who has your number. So I'll call Kevin, find out. Kevin might respond back, yes, I don't have, but I know there's someone who has it. So by the time I'm getting your number, like 20 people in between has been contacted. Are you getting the point? Okay. Then when finally I get your number, I'll now save it. Next time I'll call you directly. I'll not go the other way around to find your number again. So the same thing also we have here. So these replies, as we have said, can be spoofed, can be modified by the hacker to perform various types of attack. We have different types of attack as we'll be able to discuss later in another level as we move on, including the poisoning attack. So some switches, or today's switches, most of them will have some technique or mitigation techniques that will be able to protect against this kind of attack. Against this type of attack. Okay. So that's actually the point here. That's the point. And that's what is happening. So the issues with the ARP, it's a good protocol, but it has its own shortcomings as well. Now, how about for the case of IPv6? Now, some of the role or the functions of this IPv6, we don't call it ARP in IPv6. It's called ND or NDP, Neighbor Discovery Protocol. It provides some of the role that it provides. address resolution, router discovery, and also redirection of these services. But now, the way the operations is being performed here is not the same as the way it was done within IPv4 or ARP. So with our ICMP v6, because we have ICMP v4 for the case of IPv4, with our ICMP v6, so we know what ICMP v6 does. All sorts of communications, whether they are successful error messages, we do get them because of the ICMP, be it 4 or 6. So with 6, it has what I'm calling NS, neighbor solicitation messages. Okay, the neighbor solicitation messages and neighbor advertisement messages. Okay, so these are being used for device-to-device messaging, such as address resolution. So with this NA and NS, they're just, for the devices, PC1, PC2, and such. Then we have RS and RA. RS and RA. Again, being used for messaging between devices and routers for router discovery within the network. So this ICMP v6, therefore, will redirect messages that are being used by the routers for better next hop selection. Next device. Next hop means next device. Ideally, this is the next router. So which one is your next hop? Which one is your next device? That's why we need these particular messages. So RS is a message being sent by a device, a laptop, a desktop, to the router. The router responds back to you with the RA. Okay, with the RA. So that's the main point. So if you look at it, for the case of the address resolution here, the IPv6 addresses, just look at the structure for now. We'll actually discuss it later in details. That is IPv6 structure. So you'll find that here, so we have NS and NA. NS, that is the neighbor solicitation messages. So, hey, whoever has, okay, this address, the IPv6 address, 2001:db8:acad:1:11, send me your MAC address. Then in response, PC2, okay, again, hey, now to PC1, okay, I am this, that's the address given there, and my MAC address is this. So I'm responding back with my MAC address. That is the address resolution we are talking about. Because you need my MAC address. You have my IPv6 address, you don't have my MAC address. So the only way is address resolution by sending out that particular request. So, and that's how now it's being used to resolve the MAC addresses of a known IPv6 because it is known. It is known. Okay. Now, For the NS, ICMPv6 NS, as we have said, are sent using special Ethernet and IPv6 multicast addresses. Why? Because remember, in IPv6, we don't have broadcast. It is just unicast, multicast, and anycast. Those three addresses: unicast, multicast, and anycast. In IPv4, unicast, multicast, and broadcast. But now here we are doing away with broadcast. So now that means now multicast will perform that role within the IPv6 addresses. Okay, so that's the process. That's the process that we have there. So I want us now to have a look at one of the labs, because the main idea here is just to examine the traffic. That's the main objective, examining traffic. So let's see what we have. I'll share this activity here. Okay. So this activity, if you look at it, the main objective here, as you can see, given here, okay, part 1, part 2 that we have, is to gather part 1, gather PDU information for local network communication and for remote network. So you want to observe what happens in this case within the same network and on a different network. So this activity is optimized for viewing packet data units, that is the PDUs, packet data units. The devices are already configured, so you will gather PDU information in simulation mode and answer a series of questions about the data you collect. So part one, we want to examine the PDU within the same network, that is local network communication. Okay, so note, review the reflection questions in part 3 before proceeding with part 1. Okay, it will give you an idea of the type of information you will need to gather. Okay, this. So gather PDU information as a packet travel from 172.16.31.5 all the way to 172. So I want to believe these are the addresses here. So where's 172? Yeah, 172, 1631, 5, where's 5? Okay, 2, 172, 1631, 2. Yeah, so it means from this PC to this PC. All of them belong to the same network. So they want us to first review the reflection questions in part 3 before we proceed with this part 1. That means part 3, we're not going to, let me see, this is part 3, this part 2, step 1, okay, this, let me check. part 2. I can see. I can't see. What did you say? Review the reflection question in part 3. Did they? Part 1, yes, the questions. Part 2, step 1. Yeah. So these are the okay, they have not indicated, but these are the reflection questions that are available here. These are the reflection questions that are available. That is, answer the following questions regarding the captured data. Okay, at least to have an idea, even if you are examining the packets or the data as it moves from one point to another, then you need to have some of the questions here that also will guide you. Were there different types of cables media used to connect devices? That one will check the topology. Did the cables change the handling of the PDU in any way? Did the hub lose any of the information that it received? What does the hub do with MAC address and IP addresses? Did the wireless access point do anything with the information given to it? Was any MAC or IP address lost during the wireless transfer? What was the highest OSI layer that the hub and access point used? Did the hub or access point ever replicate a PDU that was rejected with a red X? When examining the PDU details tab, which MAC address appeared first, the source or the destination? Why would the MAC address appear in this order? Was there a pattern to the MAC address in the simulation? Did the switch ever replicate a PDU that was rejected with a red X? Every time that the PDU was sent between the 10 network and 172 network, meaning you have 10, 10, 10, 2, 10, 10, 10, 3 as one network, then 172. That's what they meant by this. There was a point where the MAC address suddenly changed. Where did that occur? Which device uses MAC addresses that start with 00D0? Okay. What devices did the other MAC addresses belong to? Did the sending and receiving IP4 address changes failed in any of the PDU? You see, remember, the main objective is to identify the MAC and IP addresses. There's no configurations. Because again, we need to understand how do we examine. If you pick a data or a marker or rather a frame or a packet within a given device, you extract it. Of course, now, practically, this will be possible with Wireshark. Practically, because Wireshark will give you all these things, because that's what the Wireshark does. It captures those traffic practically. Yeah. But with the simulations, now we have these packet trainers that we're supposed to use. So in that case, now they want us to click this IP address, which is this 1.5, the last one, 172.1631.5. Then move to its command prompt. Open the command prompt. So enter the ping 172.16.31.2. Okay, so we ping this 31.2 here. So of course, there'll be communication, yes, but now that's what they want you to examine, even as packets move from one point to another. So click on the command prompt of that desktop, then command prompt. Then you ping ping 172.16 dot 31.2. 31.2. Just confirm. Yes. From 31.5, you ping 31.2. Okay. Then they expect you to examine how the traffic is flowing here. So then enter. Of course, you can see there is communication. That's why you can see this reply. Because of the ICMP v4. You're getting that. Switch to simulation mode and repeat the ping command. Okay. So a PDU appears next to layer table here. You see, on packet tracers, there are two main modes. There is real-time mode down here. By default, when you open a packet tracer, you'll be on a real-time mode. On the real-time mode, this is actually where you can use commands. Like you see, we have ping there. We have used traceroute commands can be used while on real-time mode. Simulation mode, you cannot use commands. It's only packets, okay, that are being used. That is the other mode, simulation mode. So we click on it, simulation mode. Okay, the simulation mode, and that's actually what we have, the simulation mode. So you have this simulation panel, the simulation panel, okay, as you can see. So you just need to observe how packets now will be moving here. So switch to simulation mode and repeat the ping. Repeat the ping. Okay, so let's go and repeat the ping there. That one, enter. Okay, so you'll find that a packet, a PDU, that's a packet, has been created. Okay, next to the layers tab here, as you can see. Here, as you can see, this one, ICMP. So again, if you check on it, you'll see this is the packet. This is the packet here. Okay. Then now click the PDU and note the following information from the OSI model and outbound PDU layer tabs. That is, are they the same with what has been captured here? If you click on that packet, okay. So in that case, you can click it here. You can click it, this packet here. You click on it, and this is what will be generated. So we have the two tabs here, OSI model tab and the outbound PDU details tab. These two tabs. Okay. Then with that one, now you can now confirm what has been captured, including the source. You can see destination, MAC addresses for layer 2. For layer 2. Okay. The source, that is for the case of layer 3. Because you see, the layers, they are the layers that we have. As you can see, this layer 3. What are able to see within layer 3? What has been captured? Okay. What is the source? What is the destination in terms of the IP addresses? If you move next down here, layer 2, the MAC address. What is the source MAC address? What is the destination MAC address? It's the same as what you can see here. Okay. So those are the details actually we are referring to. Those are the details we are referring to. At device, okay, at device. So we check all this, okay, at device, as you can see up here, being captured there. So outbound details, you check the IP address, you check the Ethernet address, that is the layer 2, same details that are being captured here, both source and destination. IP, source and destination. Okay. So those are some of the things that, we are trying to examine here. So the next thing that they want you to do, or they want us to do here, click capture forward. The right arrow followed by a vertical bar. Okay, that's the capture forward. To move this PDU to the next device. Gather the same info from step 1D. Step 1D. Okay. Step 1, where is step 1D? Now they have labeled these things over there. So we have part 1. Okay. Step 2. Step 1. Step 1D. Oh, this one here. Okay. This one, step 1D. Okay. Then repeat this process until PDU reaches the destination. Record the PDU info you gathered from ping, that is 172.16.31.5 to 10.10, okay, into a spreadsheet using the format like, okay, so we expect you now to capture. You can see they've captured most of those details up for you are there. So we repeat that particular process. So now this one here, play the play, move forward. Was it move, capture, move forward? Capture, move, wait, this one here. Okay, capture, then move forward. This is actually what they're saying. The arrow, the right arrow, followed by the vertical bar, as you can see. Just to observe how the packet is being moved. Let me put it here. Okay, because it's moving forward, so it's one step at a time. Click on that. At device will be switch. Okay. At device will be switch because that's a switch. Then capture, again, move forward. Okay. Then capture, move forward. So look at what is being rejected. We know which one have we pinged. 172.16.31.2, not 172.16.31.3. And that's why you can see that red X there, meaning it is rejecting it. It is rejecting it, okay, because it was not meant for it. It's the same thing I'm saying. I'm calling Kevin, but you're not responding back because you're not Kevin. But you are hearing everything, what I'm telling Kevin. It's the same thing here. Why? We are on the same network of 172. We are on the same network. That's why that one is possible. That's why that one is possible. So that's the main thing that we have there. So now, when you get back, okay, I don't know, are we supposed to get back to, or let me see, we're supposed to reach the destination, record the PDU info you gathered from this pinging to 10. Okay. 10, 10, 10, 2. Okay. So we were to ping, where's 10, 10, 2? So, okay. So the one I've done is just for the same network, but you can now go back and ping. So I'll change first the mode to real-time mode. You can see the packet disappear there. Then I'll now ping. You can see now it has completed. It was just hanging because it was in simulation mode. But now I can ping 10.10.10.1. I'm a dot, dot 2. Dot 2. Okay. So of course there'll be request timed out for the first time because of the the search. You're searching where 10, 10, 10, 2 is. So it will take some time before the response starts. So when you ping again, there'll be no delay because already it knows where that device is located. So you can now check to simulation mode here. Then capture forward. Sorry, where is that? Simulation mode. Then capture forward. Okay, I need first, just a minute. I'm supposed to, which scenario is this? I can delete because scenario 0 is a minute. Let me delete this scenario. I don't know whether I'll be allowed to delete, just to refresh the content of what we had. Okay, then, okay, ping. Yeah, so you can see the packet now. The packet now has appeared. Okay, then now we can actually have our play button, okay, to see how packets are now moving. So look at this, okay? Look at this. You can see the request has been broadcasted on this switcher, and the switcher, as we all know, you can see now all these are now receiving that, okay? Of course, we expect even 31.2, 31.3 to reject that because it was not meant for rate. Okay. We can click next. Now in this case, next, and you'll find that even 10.3 will be rejecting it because it was not meant for it. So in that case, now, this actually what they wanted us to do, to examine the destination MAC address, source MAC address, source IP address and destination IP address of the packet as it traverses these devices. So, meaning we are supposed to capture when it was here at device this. What was the MAC address? That is, what was the destination MAC address? What was the source MAC address? What was the source IP4 address and destination IP4 address? Is what actually has been captured already here. Okay. The moment it gets to switch 1, which is here, so you see they captured these two. But of course, because these are switch, we don't expect to have now the IP addresses being captured here. A switch is a layer 2 device. So you cannot have these layer 3 addresses being captured, and that's why they're not applicable here. When you get to the router up here, okay, what was there? Again, destination MAC address. So this is what they want you to find out by just clicking on that particular packet. Then you get the layers and check the way actually we did, like here. Okay, like here. When you click on this packet, so you check, okay, what has been captured. Its MAC address. Now layer 2. Layer 2. What it entails. The MAC address are there. Okay. As it moves until we get, okay, under the details. So you just need to check on this until, okay, because everything's being captured here, including the IP addresses, okay. That is the MAC addresses, the IP addresses in each layer that it traverses on the network. So that's what, already this part has been filled for you. So it's just a matter of just comparing those details. Are they the same with what has been captured here? Okay. But it's supposed to be blank. Okay. This particular table is supposed to be blank for you to be able to capture those packets. But already it was captured for you, as you can see here. Okay. As we finalize that part, reflection questions. Now we know what they expect us now to respond to with these questions, because we had this one in mind as that process was ongoing. We had that in mind there as the process was moving from one point to another. So with this reflection, this is now very simple with this particular process. So they expect you to respond to the following. Okay. Number 1, answer the following questions regarding the captured data. Okay. Because everything has been filled in that table. So were there different types of cables media used to connect devices? If I may ask you, but just look at the topology. How many types of cable are you able to see? This topology here. Are they the same cables or they are different cables? If they are different cables, which cables are these? So the question is, were there different types of cables or media used? Yes or no? Yes, there were different there were different cables which were used as per the topology, as we can see. So which are these cable? I can see someone saying straight through cable. Yes, we have. So we have a straight through cable, which are copper, by the way. They are copper cables. So be it crossover or straight through, there, those are copper cables. So we have here solid cable, straight through cable, solid, and we have this crossover. Okay, cable. So yes, we have different types of copper cables that are here. Then which other are you able to see? Serial. This one, look at it again. You know, with the serial, use the, if you just point on this, okay, if you just point on this, you can see there, no serial port is used. It's just the Ethernet, first Ethernet port, because the serial port which is here is there but down, so meaning the port has not been used. So how do you identify these cables? Here, it's just a matter of the cables here. Just check. Here are the cables that we have. Okay, these are various cables that that we have here, as you can see. Okay, you point on each of these, you will see the names for each of these cables are there. That's how you can identify them. Okay, so copper crossover cable, etc. Media loop, wireless media, correct, wireless is there. This one, connecting these two laptops, these are wireless. This is an access point, so wireless signal being detected there. Okay, so those are the cables are actually that we have there as shown. So yes, so different cables, yes, were used to connect these devices. Number two, did the cables change the handling of the PDU in any way? Did the cable changes or change the handling of the packet in any way? No. Okay. Usually, cable does not interfere with the data, because whether you are on wireless, you are on a wireless network, I'm on an Ethernet network, a message has been sent out, you'll receive it. Okay. So cables do not interfere with the handling of these packets. No, they don't interfere with data. So did the cables, no, did the hub, number three, lose any of the information that it received? Did the hub? Now, we have seen when the packet was moved from this point to 10, 10, 10, 2. All these devices, including switch and the hub here, receive the same packet. And that packet was forwarded to these PCs, the two PCs connected to the hubs. Okay. So, to me, there are no anything. What was the question? Did the hub lose any of the? No, there were no info, okay, lost, because these intermediary devices does not interfere with any information. It's just, remember, they're just directing the packets. beta switch, beta hub, beta router. You just receive and direct. That is it. But it cannot interfere with that, the details of that particular packet. So here it's a no. Then number 4, what is number 4? What does the hub do with the MAC addresses and IP addresses? As you have said from number 3, we have responded here no. Meaning nothing was lost, okay, when the hub received it. So same thing, when it's come to number 4, nothing happened because it did not interfere with anything. So you're being asked, what does the hub do with the MAC address and IP address? Nothing, nothing, okay? So these are just a device. Remember, these are just channels, infrastructure. So they don't interfere with anything. Theirs is just to give directions where you're supposed to go. That is it, but not interfering with anything. Number 5, did the wireless access point do anything with the information given to it? Access point, okay. Access point. So this is, remember, the one was the, this now wireless device here, okay. And it is from the Ethernet. And we know the Ethernet standard, by the way, the wired Ethernet standard, 802.3. 802.3. Usually that's the standard of the Ethernet. Now going to wireless, or you expect different standard for the wireless. Usually it's 802.11 for the wireless standard. And that one, there'll be different variation of wireless as we are going to discuss in CCNA 2. Okay, in CCNA 2. So being asked whether the wireless access point did anything with the information given, okay, to it. Yes, of course, when it comes to packaging now, it will change from now the Ethernet 802.3 to the wireless Ethernet 802.11. So basically what will change is the repackaging of the same, just the repackaging. So yes, the repackaging will change here based on the 2 standards, because this another one is wireless, the other one is, wired or Ethernet. So number 6, was any MAC or IP address lost during the wireless transfer? Okay. Any loss? Any loss? Nothing. Nothing can get lost because, everything has been received, as you can see. So no loss experienced here. Number 7. What was the highest OSI layer that the hub and access point used? Okay. Now, if you go to simulation panel, we had that simulation panel. Where was it? Because we're supposed to see it. It disappeared. Where's my simulation panel? Because with the simulation panel, let me see. with the simulation panel, we are supposed actually to see everything. Let me see. Simulation panel. Oops, it disappeared. Where? I'm supposed to have it somewhere. My simulation panel. Let me see. Let me go back. Oh, it was here. Okay, it was here. But now, oh, it did not save anything. So, but now, here, for it to capture, let me just do the same. Because everything can minimize this. Then click the play button. Okay. Let me repeat it once again. Because I'm supposed to check each device. Okay, then, so you can see all this here at device, then you get the details of data. So you're being asked here, was what the number was, what number 7? What was the highest OSI layer that the hub and access point? Okay. Used. Okay. Now, what do we expect here? We know very well, by the way, hub is a layer 1. Okay. Even this access point will just be relying on data. So this is a layer 1. So it's the highest here. Okay. It is the highest. If we check the content of that at device, where is that? Hub. It capture hub. So switch, router, switch, access point. Okay. So anyway, it's supposed to be layer 1. Huh? I don't know why it has not captured. It is up here. No, it's the only one that. Can I move up? It's the highest. So it's just layer 1. Layer 1. Because a hub is a layer 1. A hub is a layer 1 device. So it's just layer 1. It is just layer 1. Okay. A switch is layer 2. A router is layer 3. So we need to know each devices and their layers. So did the hub or access point ever replicate a PDU that was rejected with a red X? Like you see, a good example is this one, a red X here. Okay. So the question is, did the hub or access point ever replicate a PDU that was rejected with a red X? Okay. So now here, if you look at it, you see this is a rejected packet. And we have seen here, including the hub. So when it gets here, you see it was forwarded to 10.2, 10.3. Here, it was forwarded to 31.2, 31.3, the same one, the same packet being taken to different points. So meaning it was actually being broadcasted here. So yes, it was replicated. Number 9, When examining the PDU details tab, which MAC address appeared first, the source or the destination? Okay. So when examining that, of course, we have seen this even in our notes are there. Okay. Even in our notes, and even the arrangement of the table. Yeah. Usually it is the MAC addresses that do appear first, and more so the destination MAC addresses, then followed by the source MAC address. Then, but the IP address will remain the same, source in that order. Okay. So when you check on that, okay, so you'll find that it is the destination MAC addresses. Where was it? You see, now that question of whether there was some, what was the question here? About the wireless. I remember there's a question about the wireless. So you can see the repackaging. You can see here, we had the wireless appearing here. So what is the question here? When examining the PDU details tab, okay, so we have both. So what was appearing first? Of course, it is the destination MAC address. If you check the Ethernet, how is the Ethernet part, you'll find that Ethernet or layer 2, so it depends where it has been captured. But you'll find that, of course, it is the destination that will appear first. It is, I don't know how to close this, but when it's captured, okay. When it's captured at device, let's see, you see that's the end device, so that's why. So you can even pick it from here. Okay, because I want to check the layer 2. So you'll find that it is the destination address appearing first, not the source MAC address. Then I hope we are almost there. So why would the MAC address appear in the order? Why would the MAC addresses appear in this order? Number 10. Okay, number 10. So now remember, with our switch, and usually there are various forwarding methods. There are various forwarding methods within a switch, including cut-through forwarding, store and forwarding. So if you look at data, usually at what point is the switch start forwarding? It start forwarding immediately it learns the destination MAC address. That's the time it will start forwarding, and that's why that destination will always appear first. The moment I know your destinations, then I have no time to waste. Not even the source. Your destination, I have no time to waste and forward you out. So that's the order. Because the first thing it's supposed to take note of is your what? Is your destination MAC address there. Number 11, was there a pattern, the MAC address addressing in the simulation? Okay. Was there a pattern to the MAC address? No, there's no pattern. There's no pattern. Okay. There's no pattern there. When it comes to MAC addressing, there's no pattern. Did the switches ever replicate a PDU that was rejected with a red X? Okay. That is number 12. No, just like the other device, was the hub. Okay. Did the switches ever replicate PD that was rejected? No. If you are rejected, you have rejected. That is it. Okay. So what if you check, if you keep on clicking it, what is going back is the one which has not been rejected. Click the play button. Okay. You see what is going back is what was accepted, not the one which was rejected there. So that's now the the concept behind that. Then number 13, every time that the PDU was sent between these two networks, the 10 network and 172 network, there was a point where the MAC addresses suddenly changed. Okay, suddenly changed. Where did that occur? Okay, this is a very obvious one. On which device did that occur? On which device? The protege, not really, not hub, not hub. On which device? Bolton, yes, on a router. Yes, Eunice, on a router. A router connects different networks. A router is the one connecting different networks. So that change will only occur on a router because now you are moving from one network. You see, you are getting on a one port to the other port. So that's the changes. So from the port of 172 to the next port of 10 dot something. So on that device, on the router device. So take note of that. It's only a router that connects different devices. I'm almost done. Number 14 or number 15? Number 14. Which device uses MAC addresses that start with 00 G0 BA? Okay. So which device uses that? Which device? For number 14. Okay. Which device uses that? So you can just check. It's possible to check. Okay. So it means you can just click at device, all of them, just to confirm that particular MAC address at layer 2. On a switch, on a router, those major devices are there, including the PC, okay? And that one again, if you just click on this, then you confirm both inbound and outbound. I don't know whether you'll be able to see this. Let me see. Now, what you can do here, this is possible That's why actually they wanted us now. You see, we click, if a device is on a switch, you click and take the details that are there. On a router, you click and take the details that are there. So it's a lot of work here. Okay, so you just need to check what is there, what's available there at layer 2, at layer 3. What is the source MAC address? What is the source MAC address, the social MAC address, source IP address? So you can see, of course, we say these are layer 2. That's why you can see layer 1, layer 2. The rest of the layers are inactive. So if you move, let me see whether I can click play, forward again. Okay, how fast? I wanted it to, okay. When it is hovering, so you can check it. You can check it when it is here to see what has been captured, because now on the layers you can see now what we have, or what is being captured, there. So in that case, let me see. So it is okay. It is it is here 00, yeah, 00D0 PA. Okay, they have not captured everything, so that's actually the point. That's the point. So what devices did the other MAC addresses belong to? Okay, what devices did the other MAC addresses belong to? So now, of course, here there are quite a number of devices. We can talk of the sending device, the receiving devices, okay? Because if you look at it, look at the other one. So if you check again the PCs that we have here, both the sending and the receiving one, you find that this MAC address belong to such kind of devices. So in each part there. Did the sending and receiving IP4 addresses change fields in any of the PDU? Okay. Did the sending and receiving IP4 addresses change fields within the, okay. Now, so as we have seen, layer 2, the MAC addresses will keep on changing based on where it has landed. But the IP addresses will not change. The IP addresses will not change. They will always remain the same. They will always remain the same. So that's the point. When you follow the reply to a ping, sometimes called a pong, you see the, okay, what is this? Do you see the sending and receiving IP4 address switch? Okay, when you follow the reply to a ping, see what you are seeing, reply. Okay, do you see the sending and receiving IP4 address switch? Of course, yes, you know to see that one. Huh? You see, when you ping or when you trace that, to expect those addresses also to be captured. Unfortunately, these are simulation. So we cannot use Wireshark here. But assuming you have those devices and install the Wireshark, you'll be able to see everything. It will capture all those. So yes, we expect that one. Then finally, oh, still another one. 18. 18. What is the pattern to the IP4 address used in this simulation? Okay. So what is the pattern to the IP4 addressing used in this simulation? So what is the pattern? Of course, as we have said, you see a router play a major role. Router play a major role here. Yes, just disappear. But I've seen your post there. You have top of source and destination. So a router play a major role. And therefore, anytime you send, you see, you send, then we expect, a response coming back. And therefore, the pattern that actually has been clearly stated here, as we have seen when you are clicking, is you send a request, then you get a reply. Send a request, get a reply. So sending and receiving kind of pattern is what is being demonstrated here. Sending and receiving, sending and receiving. Then why do different IP networks need to be assigned to different ports of a router? Okay. The question is, why do different IP networks need to be assigned to different port of a router? Okay. This is very simple, as we have said it already. Okay, anyone can respond to that one? I think at one point when I was doing my presentation, actually, I mentioned that one as well. So why do we use different networks to assign to different ports of a router? To avoid correct, Alphonse. It's just to avoid conflicts, because we know a router connects different networks. That's the point. It connects different networks. It connects different networks. Okay, that's what a router does. So therefore, we need different networks there to avoid the conflict. Otherwise, if you have the same network, there will be conflict of those addresses. Then finally, if this simulation was configured with IP6 instead of IP4, what would be different? Okay. So assuming it's IPv6, not IPv4. Is there a change? What will be the change here? It's just an obvious thing. We'll not be having separate local networks. No, still we'll be having separate networks, because we expect, again, if you are doing IPv6, just like what, I'm close to this, just like you see, these are different network, even though IPv4, these are different port, these are different port, different network. Okay, so we still expect to have different networks for IPv6. Maybe this will be two, maybe 1 colon colon. This will be 2 colon colon. Okay, they'll be different again here. Okay, but again, the question is, if this simulation was configured with IPv6 instead of IPv4, what would be different? Nothing. It's just IPv6. Instead of IPv4, it will be IPv6. That's the only difference it will be there. Else, the rest of the thing will just be the same. It's just IPv6. We will not be able to see this 1010. It will be IPv6. That will be replaced. So remember, it will not interfere with the process. The process will just be the same. no different what? IP6 address or different address there. Okay, so guys, thank you so much for your time. You can stop, please. Friday, usually don't have classes on weekends. No classes over the weekend. So that means we'll proceed on Monday. We'll proceed on Monday. So tomorrow is Saturday, Sunday, yes. So then Monday. Then Monday are there. So otherwise, thank you so much for your time. Enjoy the rest of your evening, guys. See you on Monday. Bye.